So this is SafeStop. It's our little robot project for ME106. The central idea that we had for this device was to kind of based on the idea of a camera dolly in order to support weight and kind of move it around on a camera set. And the idea of this system is to prevent film set accidents. And the way it does that is by dynamically and smoothly accelerating and deaccelerating based on any obstructions and the accelerometer on the top. We'll talk more about that later. But generally speaking, we had a cup on top for a demo. And the idea is you don't want to drop the expensive equipment on top, but you also don't want to hurt the person in front. So the device will speed up and slow down smoothly. If something is really close, it'll stop quickly. If something's kind of far, it'll slow down and stop. So that's the kind of the core principle behind SafeStop and why we made it. Alright, so to go over the actual mechanics of SafeStop, I kind of drawn this diagram here along with our CAD model here. So I'm going to go ahead and get started. So we basically have a rear wheel drive system along with a single steering linkage. So in our front wheels, we have a servo motor right here that is actuating two linkages connected to the wheels. So as the servo motor turns, these two side wheels will turn accordingly. So I think show you guys right down here. There's a servo motor and two linkages turning these two wheels at the same time together in parallel. And by turning in parallel, we're able to effectively change the direction of the car's travel without having to stop or change the rear wheel's power. So instead of having the two wheels kind of change acceleration and change like a tank, we're instead able to smoothly course along a predetermined route or via the remote.
We have the Arduino. This is a development board that we put on top of it for more pins. But this was our main microcontroller which we use to operate this robot. The next important thing we have are these motors. These are simple DC motors, and they are powered using an H-bridge, which is controlled by the Arduino. We were using a 9-volt battery to power the H-bridge, and that will be all for how the motor was working, in addition to this servo motor which we use to control the direction of the robot. The next sensor that we had is, the first sensor that we have is an ultrasonic sensor. All it does is it measures the distance between this and the nearest wall. We were also using an accelerometer. An accelerometer measures the accelerations in all three directions, X, Y, and Z. And the final sensor that we had was an IR sensor. Originally, we were planning on using just an IR sensor for a line following robot, but we switched our method to using an IR receiver and a remote control for operating the robot. Basically, front, like forward, backward, left, right. This is how we wired all our components. This was an older schematic, so not all the pins are in the right position, but our power supply powers the H-bridge, which is used to control the motors, and the H-bridge is controlled by the Arduino. And this is our ultrasonic receiver. Like I said earlier, we were planning it for it to be a sensor that follows a line, but we shifted to this kind of system. This would be our accelerometer, and this would be our ultrasonic sensor. That would be all. Okay, so now let's discuss the actual logic that we use to make this robot function. I've got a paper just for that, and so, like I said, our main thing is our ultrasonic sensor and our accelerometer working together for the smooth acceleration and deceleration of the robot. We are basically using a trapezoidal motion profile for this, and I'll explain how. So, this is an ultrasonic sensor. It is constantly measuring the distance from the current wall. If there is no wall, it has a maximum limit of 600 centimeters, and our accelerometer is measuring the current acceleration of our robot. What we are basically doing is we are setting a maximum velocity of our robot depending upon the distance that the ultrasonic sensor senses from the next wall, and that velocity is in a PWM value, which the H bridge is using to control the motors. So, the more closer you are to a wall, the lesser the target speed of the robot is. And at every instant, at every loop, and a loop should be about 70 milliseconds because our ultrasonic ping is sent every 50 milliseconds, so, and there is no blocking in there. Every loop, we are adjusting our PWM to reach the target, a PWM that has been decided by this ultrasonic sensor. And we're using this accelerometer's data to minimize jerks, because jerk is basically change in acceleration over change in time, and since time is so low, so our jerk is basically the change in accelerometer reading between the last loop and this loop, and we're doing some math to basically adjust the speed up to the target speed. Have we all? One of the few big problems that we faced while working on these projects, and like the things that we actually learned from this, is that working with a lot of sensors, integrating them together is a lot different than it sounds compared to when we are looking at them individually. Because how we're working, first thing to know about the Arduino is that there are only a few PWM pins on the Arduino, unlike a Pico. Here, the pins 3, 5, 6, 9, 10, and 11 are the only pins that you can use for PWM outputs. So if without using an extension, we were kind of limited to these few pins for the motor driver, and for the servos, as well as for the IR time, as well as deciding which pin, like which cycle does the IR sensor use. Because when we put all these sensors together, they were all conflicting with each other. For example, alone the IR receiver was fine. It was taking the commands from the remote very nicely. But we found out that when we used it in collaboration with the servo, for some reason the servo was interfering with the IR receiver. As well as we found out that the IR receiver had disabled PWM on pins 3 and 9, which are the ones that we were using for our motor driver. As such, we were not seeing any motor movement for any PWM signals lesser than 255. So we had to account for that, and we had to change our PWM pins for the motors from 3 and 9 to 5 and 11. Another problem that we were facing was that because of the interference between the servo and the IR receiver, there were a lot of signals that were unknown received by the IR receiver. As such, the responsiveness of the robot, which was not our main focus, was a bit affected. So our robot could not stop or perform any of the functions exactly when we press the button. It was kind of dependent on if the current signal was received before the unknown signal was received due to the servo. So these are some things that we would like to keep in mind when we build our next project using the Arduino, that is to see how the internal working of the Arduino works, because each set of two PWM signals on the Arduino correspond to a timer, and the IR sensor uses one timer, and the servo uses another timer. So, and they disable different PWM pins depending on which timer they use. So we have to basically keep them separated. As well as our current approach was just a trapezoidal one, we would like to shift to a PID based control in the future, which would be a lot more accurate. Although it is more difficult to tune, it would be a lot more accurate and interesting for a robot. Now, let's shift to seeing the demo of how our robot actually worked. That's nice. We also made a Gaussian splat of our robot that is basically a 360 view around it, which we will be displaying now on the screen so you can see how the robot looks from all angles while we talk about our contributions to the project.
Alright, so this is Kyle Nguyen on May 11th, and we're going to discuss kind of our contributions to the project. So I'm the one who handled most of the mechanical engineering behind the project, including the circuitry, electronics, and also figuring out the steering linkages and the mechanical systems involved. I also was the one who came up with some of the basic concepts for the logic, but I did not code them fully. That would be my partner.
Hello, I am Hemang Mehra. I worked on the other aspects of the robot. I basically worked on how to integrate all the different components that we had, all their testing with the Arduino, as well as debugging the problems that we are facing because of using them in conjunction with each other, because of the different interferences and the timer cycles. I worked on the software side of it as well, and I redid the wirings. I also CAD'd a few of the parts which were not correctly, which did not correctly come out. The entire green structure on top of the robot for testing was what I CAD'd, and all the other mounts for the sensors and the components were also CAD'd by me, and I helped Kyle with the idea generation. It was his idea originally, and we worked upon it to see how to work to implement it on the robot.